Hello, those of you at home. Let's go ahead and hop to it. Here is your warm-up. As you can hear, we're all very much done with it, so you're going to want to pause the video, find the measure of angle SAT, and then join us here. So go ahead and pause it, work on that, and here we go. All right, everybody. Can I get you back up here in 5, 4, 3, 2, 1. Okay. Okay, here we go. Uh-oh, I have counted down, guys. There's still quite a few people talking. That doesn't really work for me and doesn't meet my expectations. Okay, let's try that again. Here we go, guys. Just so you know, today what we're going to need is we're going to need to have our math notebook, pencil, calculator. There is no self-assessment today, which is actually a mistake. It turns out, remember how that self-assessment, I was like, hey, we're ready to go on that self-assessment, and I let you guys have the rest of the time, and you were like, hey, it's not available till tomorrow, and I was like, whoops, I made a mistake, and then I fixed it. Well, it turns out the original plan, if you look at our time card, was that we were actually supposed to do the self-assessment today in class instead of there, but we finished it. Like, we were good to go. So here's what we're going to do. Normally, I would do the lesson today, self-assessment tomorrow, and then we were going to do an activity on Friday. I'm going to flip it around so we actually have more time for the activity. We'll do the self-assessment today. We'll do the activity tomorrow, so we have lots of time for the activity. And then Friday, we'll do the self-assessment, because how many of you went home and did this self-assessment and found it took less than 5 minutes to do? Yeah. These don't take very long. If you know what you're doing, they're really not that bad. It's next week. Next week is where these tend to get a little bit dicier. But that's okay. We're going to make do, okay? Perhaps at the end of the day on Friday. Okay.
So wait, what's the plan? Like, what are we doing? I don't understand.
So right now, we're going to just do our lesson, the lesson that was supposed to be tomorrow. And then tomorrow, we've got an activity that I was planning on doing either Friday or either next week, but let's do it this week. Plus, the big guy's going to be around on Thursday, and that activity is going to make me look all kinds of cool. No. Oh, no, bigger guys than that. Bigger guys than that. Like the big guy. The head cheese. Yeah. Superintendent. I don't think Dr. Nye has any spicy cheese, but if he does, that would be awesome. Could you imagine the superintendent comes in and is just like, oh, yes, the only thing your class needs is spicy cheese, and like starts handing it out, and I'm like, this is awesome. Like, yeah, okay. Anyway, the superintendent. All right, anyway, moving right along in 5, 4, 3, 2, 1. William, I know that the measure of angle SAB, this guy right here, is 60.1 degrees. How can I use that to find the measure of angle SAT? Go ahead, William. I am glad we're talking. Tell me, what kind of angle is made by BAT? Uh-huh. A straight angle. How many degrees are in a straight angle? 180. How many degrees did this guy get? BAS. So how many is left over for this guy? Grab your calculator. What are you going to do with your calculator? Yeah. And what do you get? We'll call it 119.9 degrees. Negative angles, guys, they do exist, but that is something for another day, okay? Negative angles are a thing, but that's not until, you're never going to guess, 10th grade. That's true. In 10th grade, you have to worry about negative angles. They're not as bad as you think they are. But here, guys, we're only dealing with positive. So if you do that, because I think what William did was he did 60.1 minus, oh, that's 601. That's going to be weird. 60.1 minus 180. That's okay. That's okay. As long as you're like, oh, it's the negative, it's fine. And you just change it, you're good. Okay. It is the 98th day of school, guys. You know that since Wayne Gretzky's number 99 jersey was retired league-wide, the highest NHL jersey number available is 98. Nope, because you can't have triple digits on an NHL jersey. Because Wayne Gretzky, the great hockey player who might have been the greatest athlete at his sport of all time, they retired his jersey for every team forever. No one can have 99 because it's Wayne Gretzky's number now and forever. And so now it's 98. I don't think so. How many of us have seen video of Wayne Gretzky playing? Do you think it's mean or do you think it's justified? I think it's justified. You watch tape of Wayne Gretzky, and you too will think it's justified. Hey, it's library shelfie day. So go to a library, and if phones are allowed, take a selfie by the shelf. Shelfie. All right. No, I don't think the librarian would appreciate that. All right. So no phones in school unless you do it in front of me, in which case I can start. I can get another point in the contest. All right. So let's see here. I want a little bit of help from Annabelle. What's our first essential question? Holding on. Now, what are vertical angles? And how can I use them to find unknown values? Okay. Social media scandals required by law to have a U.S. headquarters in addition to the original in Beijing, the issue being its tracking of journalists using the GPS on their phones. That was indeed TikTok getting in trouble for that. And then self-care journaling. Journaling is the correct answer. Journaling is 100% the correct answer. Well, I don't think that's self-care. That's just mean. All right, so here we go, guys. Underneath all this, got a pencil? Today we're talking about vertical angles. Okay, I'm going to show you a problem that is very similar to the one that we just did. I have to be a little bit clever about how I do it, though. Hang on. Whoops, nope. Okay, so we're going to do that. We're going to make that white. We're going to make that white. You know, actually, now that I think about it, those of you at home, I'm going to blank your screen, too. Hang on. Boop. Okay, here we go. Don't worry. There's nothing to be confused about. It's going to be fine. I just have some work to do here. Oh, I see. It's making squares instead of rectangles. Hang on. Okay. There we go. No, everything's fine. Nothing weird's happening. It's all good. Okay, we're all good. We're all fantastic. Yes. Okay, looks good. Looks good. Okay. Okay. Okay, here we go. And then I'm going to take this guy and this guy. Okay, that's going to be there. Nope, I'm doing the letters wrong. Hang on. Sorry, guys, I have a plan. The plan's good. You're going to like the plan. Okay, now we're going to do this one over here. Okay, here we go. I'm ready to go. Then I got to get this very strong, get that going. Okay. Okay, here we go. Behold. Maybe. Guys. Oh, wait, those of you at home, sorry. Everyone at home is like, wait, what? What is it? What is it? Show me what it is. Okay, there we go. All right, guys. When I say teach, I want you to say, okay, please find the measure of angle BAR. Teach. I'm going to fill that out while you guys are working. Hey. You guys hanging some more of these up? Love it. Are you guys Alvarado's TAs?
Well, actually, I'm obviously, I was doing something else.
Well, that works too. It's in the office, yes. Mm-hmm. Yep. I'm sorry. I usually try to account for that. Okay, it's okay. I appreciate your apology. Thank you. All right. Okay. Come on up in 5, 4, 3, 2, 1. So we know that the measure of angle BAE is 137.4 degrees. So how can I find the measure of angle BAR, Ruthie? Ruthie? How can I find the measure of angle BAR?
Oh, you can, you can subtract 337.4
Oh, 137.4.
from 180 degrees.
Yeah.
Or 180.
Uh-huh.
And that gives you 42.6. So we know that
Yeah.
that BAR is 42.6 degrees.
Measure of angle BAR equals 42.6 degrees. How many of us got the measure of BAR is 42.6 degrees? Perfect. You guys ready to see what I was doing secretively? Because this is not the whole problem. That doesn't even say bear. It says bears. It says bears. Now, guys, have I changed the measure of BAR? So all that's just fine and dandy. So how am I going to find the measure of EAS and RAS? Teach!
They're equivalent. They're the same size.
What's the measure of the missing angles? There's 2 extra missing angles now. Hi, Lucy.
So, since like 137.4.
Uh-huh. You got the right idea. I think you're overcomplicating it, though. Because if you'll notice, I covered up this part, right? What if I'd have covered up this part? Squeeze by you guys here. Yes, Callie.
Each line is 180 degrees, which means if you were to just like look at it with the BAS line,
Uh-huh.
you have 42.6. You know, that you subtract it by 137.4, and then you can just do the other side.
Yeah,
You can see
yeah,
from your
exactly.
area.
There you go.
Also,
There you
Mr.
go.
Peterson, when can I come in to retake the?
I'm available this week, Thursday after school or Friday before school. I'll be here on 7:05. Next week, Tuesday, Thursday after school. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? All right. Guys, you did very well there. I thought you guys do deserve a point for working together on that. I think you guys did awesome. So I actually heard a lot of people say something that was true, but I want to take a step back from that, which is there were some people who were like, oh, it's easy. RAS is 137.4 because it's the same as BAE, and EAS is 42.6 because it's the same as BAR. Now, that is true. That's what I heard you say, Ruthie, and that is 100% true. But the question is, why is it true? And it was Callie that I heard say why that was true. Callie, tell me, why is that true?
Because both lines are 180 degrees.
Mm-hmm.
And if you look at them and you do the math like you did the ones going up,
What Callie's saying is that if instead of ignoring the line that I did, what if we just ignored this one instead? Did that rhyme or was that a slant rhyme? Was that a slant? I think it was like a slant rhyme. Anyway, guys, that's enough and not necessary. Okay, there we go. So if we had this, we would absolutely have the tools to fill that in, right? 180 minus 42.6. Okay. 180, yep, minus 42.6. Because it's just another straight angle, and that's 137.4. And so it turns out that that is absolutely true over here. So that one has to be 42.6 degrees for the same reason. If I covered up this line, let's see, which one do I have to cover up? I guess I have to do these ones. No. If I covered up these lines, then that would work that way, right? That would work that way. Perfect. It doesn't. You don't have to cover anything. I'm just covering them up to kind of illustrate why these wind up being the same. Okay, you guys ready to see another one? Okay, let's do it. You get 180. That's right. 100%. Can anybody think of an animal? 5 letters, no repeated letters. Whale. I'm going whale. WHALE. Now, that's enough. That's enough. I'm going to tell you guys that the measure of angle EAH is equal to 163.3 degrees. That is, this is 163.3 degrees. I want you to tell me the measure of every single other angle. Talk it out and teach. You have no idea? That's okay. Let's talk about it. Guys, if I didn't have this extra stick, what do these two make a linear pair? Do these two make a straight angle together? Sure. Right? Like if I covered this up? If it helps. Do you see the straight angle right there? So how would I find the measure of that missing angle? What could I do?
You do 180.
That's right. But the truth is, we've got a few of those, right? So go ahead, use that, and then just kind of pinwheel your way around. What's that? Seals? I can't do it because that's got 2 S's in it. But I could do seals with a Z. That's fun. Maybe we'll do that next. Okay. Alrighty. Can I get you back up here in 5, 4, 3, 2, 1? Carter, what's the measure of another one of these angles? WAH, LAW, or EAL? Doesn't matter to me. Which one?
L is 16.7.
Which one?
Oh, LEA.
Or EAL?
Yeah.
Yeah. That's okay. Because you got to watch out. Because ALE would be this angle right here, which isn't one of the ones that I'm curious about. So you just want to make sure you're saying it in the right order. Like EAL works, or LAE, yes. Okay, perfect. And what did you say it was?
16.7.
And how did you know that?
I subtracted 163.3 from 180.
Perfect. Exactly. That's exactly right. That is exactly right. Let's see here, Kelly. What's the measure of another angle?
Sorry, 1 second.
That was the one we started with. That's okay. We didn't do law?
Okay.
Mm-hmm.
16.7. That's what.
Oh, are you talking about wall? Or law? Or are you talking about law? Oh, law. Excuse me. I thought I heard law. Law. Excuse me. So now that we know that that's 16.3 degrees, we know that these two have to add up to 180. 16.7, excuse me. Thank you. Go ahead. Carry on. Law, 163.3. Hey, everybody, what's WAH? 16.7 degrees. What? And again, it's because this angle and this angle have the same measure, and this angle have the same measure. Now, there's actually a special name for some of these angles, okay? So here we go. Got a pencil? Absolutely. We're going to do this here. Two intersecting lines. And we're going to label the angles 1, 2, 3, 4. Make sure you label them just like I have them there. There's no convention for labeling those, so just so you know, you can label them however the heck you want to. This is probably the last way you would have labeled it, right? You know what would have been worse if I'd switched the 4 and the 1, though? Actually, I would have liked that better, because then it would have said 4, 3, 2, 1. Yeah, this might be the worst. The worst possible way to label it. Okay. So, there's some special names for the relationships of these angles. One of them we've already gone over. Angle 1 and angle 2 form what we call a linear pair. That is to say, angle 1 and angle 2 come together to make a straight angle. So do angle blank and angle blank. Also, angle blank and angle blank. Finally, angle blank and angle blank do too. Okay? When I say teach, I want you to say, okay, angle 1 and angle 2 are a linear pair because they form a straight angle together. What other 3 pairs of angles form a straight angle together because they will also be a linear pair? Give it a shot, and here we go. Teach! Well, pick an angle.
3.
Okay, what angle comes together with 3 to make a straight angle? They are a linear pair. So there you go, 3 and 4. They're also a linear pair. Hi, Annabelle. ¿Tienes una pregunta? Sí, poquito. Porque su hablo, hola. Anyway, carry on.
Sorry.
How dare you?
So, with these 2 lines right here are like 1,
Yes, 1 and 2.
1 and 2. Yeah, so you wouldn't be able to do 1 and 2 right going down, or would you? Because this one's also.
You could. Like, these 2 make a straight angle when you put them together. And you're right that 3 and 4 also make a straight angle when you put them together. But there's 2 other sets.
I have a question. Wait, which ones we just point to what one is 1? So it's like which one
What?
is 1?
That's angle 1 right there. Isn't that what we labeled as angle 1?
I know, but yeah, but that's not 4. No.
Are you okay, Ruthie?
No. I don't get it. How do you? What's a linear pair?
Here, pick another angle. A linear pair is a pair of angles that. Yeah, see, Annabelle's got it. There you go.
I know,
So,
but why?
because when 4 and 2 come together, they make a straight angle.
Oh, like if you decided to take away that one.
Exactly. So 2 and 1, or 3 and 1. There you go. There you go. Now we're talking. Hi, guys.
Is this correct?
3 and 4, yes. 4. Ooh, 4 and 2 actually don't make a linear pair, and 1 and 3 don't either. Because if you look at it, 4 and 2, do they come together to make a straight angle? No. So what does the same thing that 1 and 2 do? They're right next door and they make a straight angle. Did you come up with them over here?
Yeah.
Let me see. 2 and yeah, here, Lucy's got it. Take a look at what she's been up to. Talk to each other. Okay. Can I get you guys back up here in 5, 4, or should I say 3, 2, 1? That's Texas. All right, y'all. Yeehaw yourself. All right. Hey, you got the hat for it. Oh, that is, you know what it is? That's like a fancy banker man's hat. I tell you what, not someone who's been riding on the prairie like mine. Yep. Ain't nothing says right on the prairie like a baseball cap. Especially the ones what's adjustable on the back with a little bit of Velcro. Yeah, buddy. All right. So anyway, let's see what we got out there. So, Maddie, 1 and 2 form a linear pair. That is, and if you're not sure what I mean by that, you might want to put this little extra note here. They make a straight angle. Okay? They make a straight angle. When we put them together, they make a straight angle. So, Maddie, other than 1 and 2, what other two angles make a straight angle? 3 and 4. That's exactly right. If you take a look at 3 and 4, guys, does that make a straight angle when I put those two together? Yes or no? Yes. Sure. Definitely. Absolutely. What else makes a straight angle? Hey, guys, I don't know how you do it here in Salt Lake, but out in Texas, when someone's talking, we give them our attention, all right? Okay, let's see here. Liam. Two and four, yeah. I was going to say 1 and 4 don't work. 2 and 4 do, though, because they make a straight angle. 1 and 4 don't make a straight angle, right? Like, or at least, even if they did, like if they were supplementary, which we'll talk about that in a minute, they don't come together to actually physically make a straight angle. So 1 and 4 ain't gonna cut the mustard on that one. But let's see here. I could use a little bit of help out here from, that's going to be Annabelle. Can you give me that last pair? Okay, so we got 1 and 2, we got 3 and 4, we got 2 and 4. What's the last set? Careful, not 3 and 2. 3 and 2. I got 1 and 2, 3 and 4, and I got 4 and 2. So what's that last set? 1 and 3. Very good. Very good. That's exactly right. But you had a question, my lady. Go ahead.
So, what is it? So, 1 and 4 and 3 and 2 don't work because they like across from each other.
That's right.
3 and 4, 1 and 2, like on the rest, since they're like next to each other.
Exactly, in this situation. Yeah. And they have to make a straight angle. That's very important. They got to make a straight angle for that to work. And we're going to look at that in just a minute. Yep. What you got?
They have to make straight angle, so you're just pretending that you're taking away the
Right.
line in between 1 and 2.
It's kind of, yeah. Yeah, it's kind of like, so you're saying between 1 and 2, so it's like, yeah, if I do this,
Then you have straight angle.
that looks just like a straight angle.
Yeah, look at that.
Exactly, just like that. Exactly so. Okay. Now, there's another question. Jordan, go ahead.
Why can't you combine 2 and 3?
Well, I can tell you right now. Tell me this. Are 2 and 3, I mean, there's a lot of reasons. Like, number one, I can't take a ruler and put it down and make those a straight angle, right? Here's another thing, though. For this particular example, you can clearly see that angle 2 and angle 3, are they acute, obtuse, or what? They're both obtuse. Now, if I took two angles, both of which were over 90 degrees, and I added them together, would I get a number that is less than 180, more than 180, or exactly 180? I'd get a number that was more than 180. I couldn't put those together to make a line in this particular example. Now, okay, so, yes, Annabelle. Let's see. Do you need to draw what you're talking about? Because I can't see it. Could you? Yeah, why don't you come on up here and point it out to us? I'll try my best to illustrate this to the folks at home. I'm not quite following. Let me see.
So, like right here,
Shh, I want to hear.
this one
Yep.
is the 1, and like that line connects to the 1, but then the 4 connects to there, so why would that be?
Oh, I see what you got. Go ahead and sit on down. I got you. Okay. It's because, and this might be easier if you look at the 3 angles, right? Like if you look at the 3-letter way of doing it. So like, with a shout out to Isabel here, SEALZ, seals.
Yes.
Yep. So if you look at SAE and LAZ, lazy seals, That's just a funny picture in my head. I just can't get out now. You know what I mean? Like I'm just imagining a seal, and he's like sitting in an easy chair, holding a drink in the remote, and he's like, "When's dinner, honey?" And there's no one at home because they're gone. And he's like, "Honey?" Anyway, so folks, if you look at these angles you're making here, right here and right here, it's almost like if I started here, in order to get the whole angle, it's like I'd have to go out and like grab it. You see what I mean? Like it's almost got this bend to it. Because the problem is that if that's true, then literally any angles would be able to make a straight line. You know what I mean? I just need to, you know, I totally get why you're confused here, and it is kind of odd. But let's go ahead and write something down about these, and then there's one more thing we got to say before we go for sure. So got a pencil? Linear pairs always are supplementary. And that might help, is that they have to have measures that add up to 180 degrees. As you can see, Annabelle, 1 and 4, those are acute angles. And if I add them together, I'm bound to get something that is less than 180. Yeah, don't quite work that way. That's okay. We're going to work on that, okay? Now, this part's a little trickier. This part's a little trickier. So you guys are talking about angle 1 and angle 4. Angle 1 and angle 4 have a different kind of relationship. They are what we call vertical angles. They're made when two lines intersect, and it is the angles that are directly across from each other. So are angle blank and angle blank. If 1 and 4 are vertical angles, what do you think the other pair of vertical angles is? Go ahead and give it a shot and teach. All right. Can I get y'all back up here in 5, 4, 3, 2, 1. All right, here we go. Blythe, what's the other pair of vertical angles here? Sorry, Blythe, don't do that thing where you make someone else say it for you. You know that creeps me out. Go ahead, use your own mouth, please. What other pair of angles are also vertical? Angle 3 and angle 2. How many of us were able to get those there? You guys doing okay? Great, good. And there's a cool thing about vertical angles. And it's because of that thing that Callie noticed, that 1 and 2 are supplementary, they got to add up to 180. 2 and 4 are supplementary, they got to add up to 180. 4 and 3 are supplementary, they got to add up to 180. And then 3 and 1, they're supplementary, so they've also got to add up to, you guessed it, 180. Which means angle 1 and angle 4 are always the same measure. Angle 2 and angle 3 are always the same measure. There's a way that we say that in math. Got a pencil? Vertical angles are always congruent. That is, they have the same measure. It means they have the same measure. It's kind of like this. My kids, they both want, I don't know, a kickboard. Yeah, well, how about a Hot Wheel? Yeah, a Hot Wheel. I get them a Hot Wheel. And I'm just like, fine, here, you both get a Hot Wheel. And I hand to both of them, it's like, hey, how come my Hot Wheel don't look like a donut? And I'm like, fine. And I take away that Hot Wheel, and I get a different one, and I give it to them so it looks like a donut. It's the same. Those Hot Wheels, are they literally the same Hot Wheel? No, but do they have all the same measurements? No. Look, if you're gonna measure them atomically, sure, no, but for all intents and purposes, they have the same measures. Like it's the same thing, they're just different objects. That's congruent. Yeah, go ahead, Annabelle. Good. Yep. It'll be lower than 180. Yeah. Exactly. The only place it's weird is when if I have them intersect perpendicular so everything's 90 degrees, but I ain't going to do that to you. I ain't gonna do that. That's just a weird thing to do. Okay. Yes, go ahead, Jordan. Because there's a special way you label them. I think you have to label reflex angles like whoop, like that. So don't worry about it. If you don't see a Cyclops getting mad, you're fine. That's actually really good advice for life as well. If you don't see any Cyclops getting mad, you're probably fine. Okay, got a pencil? Now let's do this here, guys. We're gonna do these intersecting lines. Okay. Now watch carefully. Watch carefully. There's a little extra piece here. And we need a label. Let's see how many letters we need. 1, 2, 3, 4, 5, 6. Can we come up with a 6-letter animal? What's got no repeated letters? Turtle's got 2 T's. Zebra, Z-E-B-R-A-S. That'll work. Sorry, I was writing zebros. Zebros. Okay, now when I say teach, I want you to say, okay, I want you to find any linear pairs and vertical angles that you can find. So go ahead and talk to each other. What are some vertical angles and linear pairs that you can find in this group? Give it a shot. Here we go. Teach! Yup, what's up, Weston? You know, we're in the last 10 minutes, my friend. We're almost done here. Well, you don't have to say it like that. Oh, yeah! Finally, we'll be done with this monstrous class. Mr. Petersen with his terrible jokes and worse accents. Maddie's not disagreeing. She's just nodding. Hi.
So, is this with this line?
Uh-huh.
B, E, and B, or oh.
You could call it line EB, EA, AB, AE, BE, whatever. Yeah. Where's your notes? Do you have your notes being written? What's that?
Would it be like EBA?
I would actually just call it line AE. It's the line that goes through them. And then I saved 3. Now, angle ABE would be a straight angle. That's true. Like if I was talking about... Okay. Can I get you back up here in 5, 4, 3, 2, 1. All right. Yes, Thal, you have a question?
Wait, is there or is there not homework today?
There's not. There is not. There was supposed to be, but it's the one we assigned last night, so it's no big deal. Okay, so Thalia, I actually drew your card. Can you give me a pair of angles that are either linear pairs or vertical?
ABE.
So angle ABE, which is, that's this straight angle, okay? What would it be vertical to, or what are you thinking? Well, hold on. For there to be vertical angles, there need to be a pair of angles. So there's going to be 2 angles. Miss Claire. There's going to be 2 angles that are vertical to one another.
Is it ZBS?
So ZBS is, again, that's a straight angle. Let me tell you about this. Name an angle that you see up there that's not a straight angle, Thalia. RBS. Perfect. RBS. So RBS. So angle RBS. Now, angle RBS is actually an interesting one because there are no angles that are vertical to it. Because there aren't 2 lines that make it, right? In order for me to have a vertical angle here, this would have to actually continue out like this. And then it would be vertical to whatever this was. Think about it like this, Thalia. Here's how I think of vertical angles. Let's look at ZBE. Okay? Guys? It always comes... Every year I'm like, I'm not going to do the weird, gross story, but I have to. It just helps so much. Okay, ZBE. Imagine ZBE is a mouse. See? What mouse is that mouse smooching? Ah, it's smooching ABS. Yeah, if it was smooching this guy, I'd be like, that's weird. Like that weird angle. See, I'm getting uncomfortable already. I'm just saying, guys, if you open up your cabinet and there's a bunch of mice smooching, I say just close it and move. Like, that's it. That's it. I'm all finished here. I'm all finished here. So it's like these guys are directly across from each other like this, almost like corners, and they have to be the same bit. They have to be the same size. So it's like ZBE and ABS are vertical angles. ZBE, I don't know, and ABS are vertical. Can someone give me a linear pair? Can someone give me a linear pair? Yeah, Shreya. ZBA and ZBE. Yes. These would make a linear pair. ZBA and ZBE, angle ZBA and angle ZBE. Yeah, so it's a straight, exactly, are a linear pair. Yes. EBS and ZBA, yes they are. Yes they are. They're vertical for sure. So it goes like this. EBS should be this mouse. And ZBA, which would be this mouse, it's winking. Just wink while you're kissing. That's a weird thing to do, right? Like you're like smooching someone, you're like wink, and then they're just like nope. And that got weird. I didn't like that. Those would absolutely be vertical. Angle ZBA and angle EBS are vertical. Okay, folks. That's about all we've got time for. How many of us are feeling like we're doing okay here? Good. So one of the things to watch out for, guys, is that this, like EBR, for example, angle EBR, it doesn't have a linear pair that I've drawn, right? I can't make a straight angle with it because I don't have a line going off this way. It also isn't vertical because, again, part of it's not the straight line. Now, if I did do that, you'd have those two, right? If I did have a straight line, I could make that work. But since I don't, there's no line that's vertical or a linear pair with. That's about all we got time for, guys. If you guys will put your calculators away, head back towards your assigned seat, and I'll dismiss you with the bell. I'm going to go ahead and call that good. And again, no self-assessment.